Ladies and gentlemen, give him a warm welcome. Last speaker, Richard Griffin.
Hey guys, thanks for sticking around and stuff. Really appreciate that. So my name's Richard. My Twitter handle is Rich G, so you can get in contact with me via Twitter. So all the code that I'm going to show you, you can get at this tiny URL. So if you want to take that down, then you can get all of the demo code that I'm going to show you. While we're thinking about code, let's just step over here. Okay. So has anybody heard of Windows Phone 7 contrib? Woohoo! Come on. 2 people. Wow. Okay. More questions then. Who's building Windows Phone 7 apps today? Okay. Excellent. And how many people have them in the marketplace? Okay. Cool. Cool. So this is the site for Windows Phone 7 contrib up on Codeplex. Another quick thing I want to show you is this app site template, so that if you're building an app, one of the big things is kind of, you put it in the marketplace, and then how do we get people to come and find your app? So what we built was this app site template, and one of the apps that I have in the marketplace is called FinderPad, and this uses the app site template. It's really, really simple. Download the code, pull up your app inside of the emulator, take your screenshots, put them into a directory, push your HTML up onto the server, and there you go. You have a complete site ready to market your app. Couple of other resources. Use MVVM Lite. Presumably more people have heard of that than the contrib. Some of the concepts that I'll talk about a bit later, dependency injection. Do we get dependency injection, or is this fairly new? Okay, so it's fairly new. Okay. And those are really all of the pieces to the puzzle. So what I want to talk about is data-driven. Now, pretty much all the apps that we build are, process data. So let's get some context. And the context really for the session is when we're on our device, most of the time we're calling out to third-party services. They might be free, we might own them, but that's pretty much what we're going to be doing. So I think there are possibly more, but for me there are 4 main categories that we need to cover. First one, how do we get our data, the data retrieval? How do we process the data? How do we virtualize that data in terms of caching to improve performance? And finally, the visualization. How do we render these data objects on the screen? So most of the time when we sort of call out to these services, they're going to be returning something. And in general, they'll return JSON. Most of them also support XML. How else do we get that data? Well, one of the mechanisms that I'm going to show you how to do that is using RX. So are we familiar with RX? Okay, so that's fairly new as well. Okay. The RX stuff that I'm going to show you is complete boilerplate. So you can just copy this stuff, whack it in your app, change some of the parameters, and you're going to get all the goodness. So how do we handle the data? What kind of architecture do we have in place to deal with this? And once we've got the data, How do we bind that to the UI? What kind of structure do we have to do that? What kind of layers do we need? And I think one of the important things for me to get across to you is that the data that's coming down from the endpoint doesn't always marry up to the data that we want to push out and render onto the display. So you'll hear me talk about something that I call map and wrap, and that's basically taking these resources that come down from the server, mapping and wrapping them into our model on the client, and then rendering those out onto the screen. The other thing that's kind of important, and because we're in the land of XAML, we want to take advantage of IMPC, the iNotify property change mechanism that we have, so we can get the benefits of what's in the framework underneath us. So the visualization piece, we can do that in a number of ways. I guess a list is probably the most common. More exciting ways of doing that, charts or maps. Lots of really interesting ways that we can make our data look and feel innovative. And I think, the crux move to all of this, the thing that underpins everything is that we really need to deliver awesome user experiences. And I'm going to show you some tricks on how you can leverage the power of what's on the handset, even though the handset isn't as powerful as desktops or laptops that we use today. And we'll cover off some of those 4 things. Bottom right-hand corner, Yagni. Does anybody know what that stands for? You ain't going to need it. And that's one big thing on the phone. Defer everything. If you don't need to process it, don't process it. Just wait. Leave it. Because if you start processing this extra information, you're taking up space and processing time that other things, which are slightly more important to the user. So what's in your toolbox? So we've got Visual Studio 2010, we've got Blend, and then everything else I'll show you is open source, complete open source. So you can go and get that code, and if you'd like to contribute as well, that would be fantastic. So what's in the contrib? There's a lot of stuff in the contrib, and I can't really sort of decompose it onto one slide, but effectively, we have MVVM Lite at the core of what we do. So we take advantages of the messaging pattern that's in there. We've extended the collection mechanism so that they're thread safe. And then in terms of the services, what we've done is, for things like the location service, is that we've wrapped those up with some RX loveliness, and that means that, if you want to use location in your app, it's literally 2 lines of code. We also have some UI controls, and I think the one to look at are the transitions. So we do all our transitions in C#. Because we do all the transitions in C#, it makes them really, really performant. And you'll always see them happen, which sometimes if you guys have used the transitions from the toolkit, then you might find some performance problems with those. Okay, so let's say hello to Finderbad. So this is Finderpad, and when I thought about building an app, I thought, what am I going to build? What am I going to build? I need some services. And what I found was that there's this wicked company called Nestoria in the UK who provide a free endpoint that you can go and hit, and it brings down information about property. So what I'm going to do is I'm going to go and do a search. The properties come back. I can scroll through the list of properties. You see that none of the frames are dropping. We have infinite scroll. And then I can select a property. We have some extra features here at the bottom. Let's try, see if I can get a root. Let's go for broke. So one of the other things that are in the contrib is that I built a complete API wrapper around all of the Bing services. And that leverages all of the REST pieces. So I don't know if you guys have looked at the Bing Maps on Windows Phone 7, but by default it uses WSDL. And it's pretty heavy and it's pretty slow. So built this wrapper. Everything's wrapped up in RX. It's 3 to 5 lines of code for you to get sort of maps and those kind of things into your application. So, interesting. It's actually telling me to. I wonder if it tells me to go on the tunnel. Wow. Okay. So I can go back. In terms of visualization, we can have a look, see the most important thing, and that looks like the property for me. There are a number of pubs around the corner. And then all of the information that you can see here is coming from Bing. Another contrib control is the smart text box, and that supports email or phone numbers or Twitter, and you can touch that, and as you can see, it's picked up its phone number. Do I want to call it or don't call it? Okay, so just quickly come all the way back, and I just want to show you this other feature. So one of the things that I mentioned in the slide was user experience. Now, we're on a handset. We have a number of different connection types. Wi-Fi, 3G, or hardwired into our PC that's picking up the connection that the PC's wired into. And when we move from those different connection types, as you can appreciate, bandwidth increases and decreases. So what we did, we put in a little feature that said, depending on what connection type is, go and get X number of results so that the user can change the number of results that they want to come back, and hopefully this keeps the experience an enjoyable one. So that's Find a Pad, and what I'm going to show you is some of the steps that we went through in order to get there, and believe it or not, that took an incredible amount of effort. So what I'm going to do, we'll go through 4 different versions, sorry, and each time we'll refactor some pieces till eventually we get to a super performant list. So what's in version 1? I'm going to show you some HTTP web request. Nestoria returns JSON. It's a pretty mature API, actually. It's very, very nice. And in order to deal with the JSON, we use JSON.NET. I'm going to show you some map from wrap, and we'll have a quick look at some of the pagination. Okay, so let's get our coding shoes on. Right. Actually, I can't do that, can I? Because I'm going to have to show you on the phone. Unfortunately, installed some software for the camera, and it's the Nokia Lumia doesn't like that. So V1's super simple. It's just to test whether or not we can hit the service and what sort of data is coming back. So I've put in London. I'm going to hit the search button. We can get a response. You can see that I've brought back 50 in our first hit out of 4,000. Well, that's 43,000 results. And this is one of the problems. You make a request to the endpoint, but no idea what's going to come back. I don't have any control over the third party. And as you can see, 43,000. Wow. Imagine putting all of those into a list. So I'll show you the pagination. We can paginate up. We've got 100. And if you start looking at the memory usage, you can see things coming up. But importantly, the delta's not getting hoiked up incredibly high. So that's V1. Let's have a look. I hope you enjoy my color scheme. Okay, so normally what we would do is we would use HTTP web request. And we do that in some asynchronous fashion. I go and do the get on the URI, get the response, get a hold of the stream, pass the stream into the JSON reader, serialize the JSON, deserialize the result, take the service objects, wrap them into my model, and then boom, update the UI. So we probably do a lot of this today, and this code isn't really that complicated, but when you've got a lot of this, I have management issues. I can't deal with everything that's happening, and anyway, it all sort of goes wrong. So what we did in the contrib was build something which is called the resource client. And this is the resource client. And we use Rx, like I mentioned before, but hopefully that's pretty readable. So we're going to use the resource client. We're going to say what type we want. It's JSON. We're going to say we're going to get a get. What are we using to get the get? We're getting the location from out of our text box. And we're also saying what the page index is that we want. We observe everything on the dispatcher. So just like how you do your dispatcher stuff at the moment, that's what the Rx is doing. We subscribe to the result. We map and wrap. We stuff them into the OC. So a little bit cleaner, a little bit more human readable, and a lot easier for you to manage. And hopefully, even if you haven't done much Rx, that is fairly simple. So that was V1, pretty simple. What did we see? We saw that, well, we had this really nice generic pattern based on the resource client, and we also did some map and wrap, nothing too taxing. And what are the bad parts? Well, the bad parts really is that the UI is completely unusable. Nobody's going to buy my app on the marketplace. But also, everything is just in this one enormous blob. I can't test it. If something goes wrong, it's spaghetti. So with V2, we'll look at data visualization. And in order to do that, we need to change our app architecture. So this is where the DI pieces come in, and we'll hammer out this in some code in a minute. So what I have now is I have a bootstrapper. The bootstrapper is basically where my DI happens. This is all the scaffolding for my app. I've split out my views. I use a view model locator, same as in MVVM Lite. I've got a model. I've got a view model. I've got some services. And then over on the other side, we have all of our dependency stuff, DI, func, and the contrib pieces. Okay. So what I'll do is I'm going to refactor version 1 into something that looks a bit like that. And you'll hear me talk about single responsibility and separations of concerns and DI and all those kind of good codey pieces. So let's take a look at the code first. Okay, so You can see now the difference in my project. I've got quite a lot of stuff going on. What I have at the top, I put all my converters into a converters area. Memory diagnostics, this is Peter Tools, helper. All my messages, again, these messages are used by MVVM Lite, so if you're using MVVM Lite, you should be familiar with those. If you're not, MVVM Lite uses a mediator pattern. It calls it the messenger in that circumstance, but if you're familiar with Gang of Four and patterns, it's a mediator pattern. I have a model, it's my client-side model. I have a resource vault, and the resource vault contains all my resource dictionaries. And what I do there is I split everything up. I say all my common control skins and templates, they live in common controls. All of the stuff for my converters, they live in converters. And hopefully you get the gist of what's happening there. So in terms of services, these are my property services that are going to go and get the data. I've got some view models. I've got some views. So let's start with the bootstrapper. This is where everything begins. And what you see here basically is that rather than having a class and newing everything up inside of that class, with dependency injection, you remove the dependencies and you put them on the outside, and effectively then, I don't do new. I push the creation of those objects down into Func, which is my DI container of choice on the phone, and I let it deal with when it needs to new something up. So you'll see in the scaffolding that I have no news, which is nice. So what do we have here? I have a debug log that I'm registering. I have my messenger. And this is quite an interesting one, the last messenger replay. So for you guys that have done Windows Phone 7 development and you have multiple pages, there are a couple of ways that you can move data between the pages. You can use a query string mechanism, or you can use the mediator pattern. But one of the problems with the mediator pattern is that the view model that you're passing the message to, well, it might not be invoked. So you pass the message, the other view model hasn't been instantiated, it will never get the message. So what the last replay does is that when the new VM gets instantiated, the message gets replayed. If that VM is interested, it will pick it up and process it. I have a navigation service, and that's for navigating, believe it or not. I have my resource client, which is going to do all of our HTTP web request type stuff. I have my actual service, and then I have my view models. And you can see here that once I've registered everything, then I resolve things. And I resolve them by calling the resolve mechanism and pushing them into the constructor. And that means that the search view model and the results view model doesn't do anything up inside. It's all of its dependencies are being injected into it. And what that does, which you'll see, is that it forces me to have a particular structure. And that structure means that I really have to fight if I don't want to do single responsibility, or if I'm trying to munge everything together. Because we're injecting the dependencies, it's constantly breaking you. So you can't do that. So by putting these simple techniques in place, it means that you get a great architecture. Just because you have a great architecture, as I'll show you, doesn't mean that you get great performance. So that's the bootstrapper. We go to the search VM. The search VM is the thing that does the search. I pass in my interfaces. I have my execute search, which is what we saw earlier. Now I've added a couple of extra things into here, and what we need to do is say, well, when the data comes back, we need to do something. We need to navigate somewhere. And that's what we're doing here on 98 downwards, is we're saying, get hold of the messenger instance and send a message. And then get hold of it again and send the results message. And once you've done that, I want you to navigate to the results page. Fairly straightforward. Let's go and look at the results view model. I have an observable collection, an OC. It holds a type of property. Oops. Okay, this is a good bit. So what you saw, hopefully, on FinderPad was that when I was scrolling down the list, you didn't see a button that said, go get more data. We had this infinite scrolling mechanism going on, so when you start hitting the bottom, we start going getting more data. And effectively, the way that I achieve this is by using a relay command and then hooking this relay command up to a little piece of sizzle dizzle from Daniel Vaughan. I'll show you that now. And we can see here, this is where we hook up the attach property. And basically in the code, Daniel says, when you get 80% down the viewport, fire a command. We've wired into that command. And when that command fires, we'll go and get more data. And that's where we do that. So again, boilerplate code. Exactly the same code that I had in the search view model, I've got back here in the resource view model as well. So what we're doing here is a property service, calling a search, passing in some parameters. We observe on the dispatcher again, and we subscribe to add properties. And what add properties does is add properties takes care of the map and the wrap. So we take the resource, we map it into a property model object, and then we push it into the observable collection UI updates. Okay. Let's just go and take a quick look at the service. Service implements an interface, which is iObservable, and then we have our property service. And you can see here, this is doing all the work with regards to the hitting the Nestoria endpoint, and then there's lots of other goodness in here as well with regards to how we go and get that data. And one of the things to note here is that, rather than observing on the dispatcher, we're actually observing on the thread pool. So that just, when you're doing background things, using the thread pool is more appropriate than using the dispatcher. Okay, so I think that's pretty much everything. Got our views. Okay, so let's just swap back to the phone. Oops. Go to version 2. We'll keep London because I know that there's a large number of properties, and I'm going to hit search. And now watch what happens. So I scroll through the list. List disappears. Drops the frames. But in general, it's fairly good. So you can see there how the frames drop on occasion. I don't know if you guys have seen that in any of the apps that you've built. When you start interacting with the list box and start using it fairly violently, I guess, in certain circumstances, then you'll see the frames drop, and you'll see that the visual tree, the UI composition thread, can't keep up. And that's not a great experience. Okay. So in V2, we saw how we used dependency injection. We saw how we changed our architecture so that we had this separation of concerns. And I hope that you'll sort of agree there that the structure is cleaner, it's meaner, it means we can unit test. Things are looking nice. However, we had an increased memory consumption. I guess that's fairly obvious because we're using some UI controls, but the consumption, which unfortunately I can't show you, is going up and peaking around 33, 35 megabytes, which, hey, come on, you know, it's a list. I've got about 50 properties in there. That's fairly high. That then has an effect on the performance, and that, you know, then has an effect on the experience of the user sort of saying, you know, I'm removing this app from my handset. So let's address the performance. So when I started talking, I said, let's take full advantage of data binding. Let's bind up our observable collections into the XAML. Happy days. One of the problems with that you probably don't see if you're building Silverlight or WPF apps is that you have completely lost control over your data. And that's a problem on the phone because what's happening is that we're pushing all this information into the OC. The observable collection's firing iNotify property changed events, and it's doing it so much that the UI thread can't actually keep up with it. So that's why we see some of the performance problems. One potential way that you could do this is you could batch. So we could say, you know, take 20, stick them in the observable collection, fire the IMPC, get the next 20, batch them up, put them in. I don't really like that approach, unfortunately. So the analogy that I came up with is something which is called a trickle collection. And it's a form of data virtualization. And in effect, what I'm doing is I'm trying to control the flow of the data coming through, and I'm controlling that flow by having a tap. So the bucket doesn't overspill, and we manage to maintain this level of data. So effectively, the trickle-to collection sits in between your resources and the view. You give it an OC, an observable collection, and you let the trickle-to collection provider update the collection for you in a timely fashion, which then means you regain control over your data. So let's go and take a look at that. So I'm going to head to the results view model because this is where the action takes place. I keep my observable collection from before. I keep my relay command for the infinite scrolling. This time I've added a flag to say, hey, the search is in progress, and that's going to help us with some management stuff. I've set up my trickle-to collection. I keep my messages, and let's head to where the action starts. So when the user starts scrolling, command fires. That command calls the execute search. We say that the search is in progress. We increment the page index. And then we do some very simple RX sizzle. And we subscribe to this new method, which is called setup and start trickling. Let's get that on the screen. So what we do here is we new up the Trickle2 collection. We give it something to handle when a property's added, and we give it something else to deal with the callback of when it's completed. We kick off our trickler. We give it a time period. We say to it what the destination is, and we pass in our observable collection of the properties. And that's pretty much everything that we need to do. So let's switch back to the phone. Do a search, start scrolling. You can see now that it's paging. When I'm scrolling, we stop adding. But as you can see there, I'm still dropping frames. And what you'll also notice, which you can't see here, but I'll show you in a minute, is that the memory consumption's gone up again. So better. We're getting better. We've got a better management of the data. And we're kind of stopping some of these dropped frames. You saw it again there, hopefully. Okay. So, reflections, what are the good parts? We regain some control over our data binding by using the trickler, by putting this data virtualization between us and the observable collection that we're binding our view to. We've improved our infinite scrolling. So we're saying, only add the data, new items into my list when I'm not scrolling, and when I'm scrolling, don't add any more items. Bad parts, UI performance is still not great. It's not too bad, actually, on my Nokia. On previous handsets, it was pretty dire. And we've increased memory consumption. So let's look at performance again. And what can we do now to improve these problems that we have? So what I'll show you is we can put some caching down at the service layer. That will prevent us making all these additional calls that we don't need to do. I'll show you how to use the low-profile image loader so that we have an asynchronous mechanism for getting the images in the list. And I'm going to refactor some of our XAML so that we have a slightly improved layout mechanism. And we'll make a subtle change to the user experience. Okay, so let's have a look at number 4. I need to just jump into Blend for this. How many people use Blend? Woo! How many people building UIs in Silverlight that are not using Blend? Boo. You should really take a look at Blend. Make you much more performant in terms of the amount of time that you'll save when you're building assets. So I jump into the data templates. I have this data template, which is the template in my list. And what we can see here is that, you know, if I was in Silverlight or WPF, well, using a grid's pretty cool, right? I've got plenty of rows. I've got a number of columns. Really helps me with my layout. Everything's cool. Or is it? All of the icons that you see here, they're all vector graphics. Again, if we're in Silverlight, WPF, vector graphics are cool. Yeah? Performant. Yeah? Doesn't seem that way on the phone. So what we can do here, so we come into version 4, we go to the resource vault, go to the views, go to the results page, go to the data templates, select the template, and note. I've changed the grid for a canvas. Now, admittedly, the canvas isn't particularly great because I have to position everything at a X and Y, Z coordinate. But here on the phone, I can't do this with my windows. So I have a fixed width and height, so I have to do a bit of logic when we change it, but hey, I'm getting better performance. That was the first change. Second change, I've removed the vectors, and I've just put in an image. Okay, so let's just jump back to Visual Studio. Let's find my template. Okay, so we can see the images that I've put in and swapped out those vectors. The other thing to note, I've put bitmap cache on all of my images. This really helps load time. So those simple tweaks on your existing layout really help to improve the UI performance. And it really helps the UI composition thread when it goes to render the visual tree out on the screen. It hasn't got to do lots of extra work now. You're giving it the rawest and meanest things, and it just goes ahead and processes those a bit more efficiently. Okay. So how about the actual image that we're showing for the property? So for that, we use this attached property called the low profile image loader, and really nice piece of kit. Takes care of all the asynchronous calls for me for the image and deals with it, and you'll see the improvement. Okay, so that's my template inside of the list box that we've refactored. Make that lighter and more efficient. The other thing I want to show you is that previously, in the previous versions, I was using a list box. And now what I'm using here from the toolkit is something called the long list selector. And believe it or not, it does exactly what it says on the tin. It's really cool for dealing with long lists. Also notice, though, that I've lost my infinite scrolling. I can't apply the relay command that I was using before onto the long list selector because the composition of the control is different. I'll show you how we get around that in a minute. The other thing about the long list selector is that it gives me some really nice, funky dependency properties there that I can play with, and I can make it bouncy, and I can also change the look and feel of the list. Okay, so let's have a look at some other changes. I mentioned that I removed the relay command for the infinite scroll. Luckily, the long list selector provides me with some events that I can hook into. Scrolling completed and scrolling started. And what I'm doing is I'm basically hooking that value up to an IMPC that's hanging off my view model, and I'm saying, are we scrolling? Yeah, set the value. Have we finished? Yeah, set the value. Okay. One thing I missed actually before, which we can have a quick look at now, is that I mentioned the transitions, and that we do transitions in C# in the contrib because they're slightly more performant than the XAML approach, and this is how I do it. All of the pages that we use derive from something called animated base page. That has some really nice pieces to it, and I have two overrides. The first one is basically me just saying, I want to use the slide transition. And when we go one way, slide left and fade out. When we go the other way, slide right, fade out. If you've used the animation transitions in the toolkit, it follows exactly the same pattern. It's just that we do it in code. The other thing that we have is we have a little callback mechanism that says when the animation's complete. And what's quite nice about this is that when I come back, when I navigate back to the list, I can set the selected item of what's in my list to be null, so it makes a much nicer user experience. Okay, so let's now go and have a look at our view model for results. Remove the relay command. Trickler is still in place. The messages that I have registered for are still here. Here's my IMPC for the is scrolling. And what we're doing here is we're basically just syncing up the long list. Sorry, not the long list. We're syncing up the low-profile image loader with the trickler. And we're basically saying, if you're scrolling, suspend getting any data and adding it to the list, but also suspend getting any images, because we want to have a good experience. Then, when we stop scrolling, open the floodgates. Go get more data, go get more images. You can refine this, and I did refine this in FinderPad so that when you're scrolling up and down, and you start scrolling to the bottom of the list, and you stop, identify where the viewport is, and then we go and get that bit of information first, and then we start pulling in the rest of the data. So it gives this effect to the user that we're super, super performant. Okay. Now, I need to show you the bootstrapper. And what you'll see here in the bootstrapper is an additional piece of scaffolding, which is my caching provider. And supports different types. But for this particular instance, I'm using an in-memory cache provider. I could pump this to isolated storage as well if I wanted to. But for the sample, we're just putting it into memory. And then we pass the cache provider into our services, and that will then ensure that the service uses our cache. Therefore, if we're making multiple requests for the same thing, we only do it once. Okay. And I'm pretty certain those are all the pieces. So let's take a look at the sizzle. Let's see how much better it really is. I can find the application. There we go. There it is. Okay, so we do another search on London. Start getting data. Pretty good. You can see when I scroll, we're not adding any items in. When I stop scrolling, we start adding more items in. Scroll down a little bit more and get some of these items come back. Just load it up with some data. Get some more items in here. Okay. And what you can see here is that the images are coming in at a slightly delayed pace. And where we kind of move quite quickly, we're still waiting to get those images. But as soon as I stop, I know where we stopped. We go get the images. So we're up to 80. Should we try and get up to 100? We can go higher if you want. Okay, let's get to 100. Okay, there we go. So I can frantically scroll up. Nothing drops, no frames. All of the visuals that I put in there are present. I pressed the wrong thing there, sorry. But you can see now how all of those pieces, when we put them together, really gives a fantastic experience, which is what's going to make your app popular on the marketplace. No frames are dropping, nice and slick. Okay. So what did we just see? We saw the low-profile image loader being hooked in, which one-liner XAML gives you all your async stuff. That's quite nice. We've improved the UI performance, so everything now is really fluid. We're not getting any frames drop. We've changed very subtly our user experience, so if we are moving through the list, we're not adding any items. When we stop, we add the items. When we stop in a particular viewport, we stop getting any of the data above us, and we just focus in on the data that needs to be brought back. And what we've done, which unfortunately you can't see, is the memory consumption has come crashing down. So these are the performance things that I wanted to show you, but unfortunately the driver for the camera, the Nokia Lumia doesn't like. So what you would have seen, or if you go and download the source code and put it onto your handset, you will see is that when we built that really simple POC, what are we using? 15? Sweet. But we're not really doing anything. We're just getting some data and bringing it back. So we should expect it to be that low. We then slapped a list box on top of that, and wow, we jumped up to 42. We're over double. Not good. Considering it's just a list box, and this is one, we have 2 screens. Wow. In FinderPad, we have about 8 screens, so we're going to hit the 90 megabyte limit very quickly, and then our app will go. So not a good place to be in. We refactored version 2, and we put in the trickle collection code. We regained some of our data. It was pretty good. It came down a little bit. And then finally, the combination of the caching, the low-profile image loader, some tweaking on our XAML, we come crashing back down to 33. So that was my experience of building FinderPad, was that you kind of do these things expecting things to happen. Everything looks great. You look at the memory, Oh dear, this isn't going to run. So what are the takeaways, really? It's all about performance. I really can't sort of stress that enough. And in order to get that performance, hopefully those techniques that I've showed you and the other pieces in the contrib will help you get that performance that you need in your apps. XAML, it's good and it has bad bits. So just be careful when you're putting together your data templates. Just be mindful of how much XAML you're putting in there. If you're creating really complex layout, that is going to hit you. And you have to kind of think, does it need to be that complex? Can I simplify it in any way? And as soon as you start simplifying it, you'll start to see improvement on performance. All of the bits and bobs that I showed you, open source, apart from the Visual Studio 2010, of course, and Blend. And the other big takeaway, really, is create an experience that's right for the device. I can't stress that enough. You know, if you're taking a massive website and you're trying to deliver the same sort of functionality and experience, then you're not going to get there, unfortunately. You have to rethink that user experience and make it leaner and more appropriate to the device. And that's pretty much me. Some slides, a slide there with more info on it, which you've possibly seen before. I'll be around for about the next 30 minutes, so if you have any more questions or want to have a play on the device, buy me a beer, I'll be sticking around. So thank you.